So day one of algebraically solving these things. So yesterday was all graph it, find the x-intercepts. That was pretty easy. Today we're going to do some algebra stuff. So we're sort of back to real math, not just calculator world. Step one is isolate the trig function. So if we have 2 sine x plus 1 equals 0, then I want to get sine of x by itself. Let's clarify this a little bit, and then we'll do it for this problem. When possible, isolate the trig function. So that's the sine, cosine, tangent, secant, cosecant, cotangent. Get that thing by itself by manipulating the equation so that the trig function is alone on one side of the equation. So this is like solving for x or y or anything else, where you're going to add things over, subtract things over, multiply, divide, square root, whatever, to get sine of x by itself. So let's subtract the 1. Some of you hopefully do this stuff in one full step now. I subtract 1, move it over, and then divide by 2. Sine of x equals negative 1/2. Now I've isolated the trig function. And now this problem, I think, got a lot easier. Then ask yourself what the reference angle must be for that trig function and trig value. I would draw a picture at this point. It helps me visualize. Where is sine negative? What quadrants have a negative sign? Say that again.
3 or 4.
4 for sure. 3 and 4. The down ones. Because sine is the y coordinate. So there's the 2 places where it happens. I don't want to say the 2 answers because there's an infinite number of solutions, but there's 2 places on the unit circle. And they both are, this is the reference angle thing, they're both over 6. Rather than write it all out, use all students take calculus, or just your knowledge of where things are positive and negative, to determine which 2 quadrants the reference angle function must be in. Now that we are solving an equation, there are blank number of solutions. How many solutions are there? Infinite, right? So it happens 2 places on the unit circle, but because we can get there so many ways, there's an infinite number of solutions. This is different from our work with inverse functions. So do not restrict the quadrants. Right, so the rules about which ones come from 1 and 2 versus which ones come from 1 and 4, we're not doing that because we have equations today. That was only when we were doing inverses, so don't do that today. Use both quadrants today that make that trig function that side. So that's a lot of words to say. Don't restrict your answer. Just give both answers. I think that's the easiest way to say. And remember, it's similar to if x squared equals 9, then x equals plus or minus 3. But if you have the square root of 9, that's just 3. Today we're doing the plus or minus side of things. We've got multiple answers. So actually, let's go back and finish this problem here. Oh, I don't really like this because it didn't specify. I didn't specify. But what angles does this happen at? Like what are these two angles? I know they're both over 6. Okay. 7 pi over 6 and 11 pi over 6. And I'm not worried about 11 pi over 6 versus negative pi over 6 because we're not worried about that restriction stuff anymore. Now, those aren't the only answers, so may as well address it here. I can add 2 pi to get another answer, but I could also add 2 pi any number of times. So we end up putting plus 2 pi times k, where k is an integer. So you can rotate around 100 times. So add 200 pi to 7 pi over 6, and you'd still land at that spot. So the plus 2 pi over 2 pi k stuff is what gets us all of the answers. That's the infinite number of solutions thing. The 2 pi k will get us all of the solutions. All right, that's not too bad if you know your unit circle. If you still don't know your unit circle, today is just going to be a disaster. I don't know how else to say it. Like, you've got to know your unit circle. What makes today a little tricky is trig function or trig arguments. Argument is the thing you're taking the sine or cosine of with coefficients. So let's do cosine of 2x equals 1/2. Oh, you know what? Let's do sine of 2x equals 1/2 because that's what it said to consider. Sine of 2x equals 1/2. Treat the 2x, which is the argument, treat the inside like a single angle. So you're thinking, well, what does the sine of what, so ignore the fact that it's 2x, the sine of what equals 1/2? Set the 2x equal to the angles that make sine equal 1/2. Set the This feels formulaic when we fill out notes, but I don't know how else to do it. So just sort of ignore the fact that there's a 2x in there, and just tell me, well, where does the sine equal 1/2? Again, maybe a picture is needed, maybe not, especially since we just did one similar to this. So that means whatever's in there has to be pi over 6 or 5 pi over 6. So that means 2x is pi over 6 or 5 pi over 6. Now, if we divided both sides by 2 to get x by itself, that's not going to give us, that will only give us the answers, or the x values, that's why I'm not doing it yet, between 0 and pi, because we divided by 2. So normally our answers are 0 to 2 pi, but if we divide by 2, then our answers are between 0 and pi. So there's more answers out there. Like to get the remaining pi to 2 pi, the rest of the answers, we need to come up with some more angles before, that's why I didn't do it earlier, before you divide by the 2. Here's a little bit of a trick. If the coefficient is 2, you need twice the number of angles. If the coefficient is 3, you need triple the number of angles. If the coefficient is 4, we probably wouldn't do that to you, but you'd need 4 times the number of angles. Add 2 pi to each angle to get more angles. Then divide both sides by whatever the coefficient is, by the coefficient. Okay, again, a lot of words, probably easier to just watch one being done. So 2x equals pi over 6, but that's only one of the answers. Let's make it pi over 6, and if I added 2 pi to that, that would get me 13 pi over 6. And 2x equals 5 pi over 6, and if I added 2 pi to that, that would get me 17 pi over 6. And then I can divide everybody by 2. Or, probably easier to say, multiply by a half. So pi over 12, 13 pi over 12, 5 pi over 12, 17 pi over 12. So there's my answers between 0 and 2 pi. The 2x doubled the amount of solutions I had. Normally we think we have 2 solutions, but the 2x'd our number of solutions. It's an easy way to think of it. All right, we'll work some more of those in a minute. We will use the calculator today, but we have to be careful with the calculator, and here's how. It's worthwhile to mention the inverse trig capability of calculators. So we know we can hit inverse sine or inverse cosine on the calculator. But that only gives us one of our answers. So you must find the other answers using all students take calculus. This says logic. I don't know if that's the right word. Math, quadrants. You just got to figure out the other one, and I'll show you. We'll look at some examples how. Or you can use the graphing technique. I don't really like this one because it takes too long. That we learned yesterday. Well, I say I don't like this one. If I give you your calculator, then I don't care whether you use the inverse function or the calculator or the graphing function. Either way. Let's do some examples down here because these are easy. Sine of x equals 0.734. Sine of x equals 0.734. So that means x is the inverse sine of 0.734. Inverse sine 0.734 is 0.824. It's like, okay, that's right, but let's back up a minute here. What quadrants have a positive sign?
First and second.
First and second. Thank you. This one, inverse sine comes from first or second, or excuse me, first or fourth. So we have the right answer, but we only have one right answer. So I've got one of my answers, but I have to figure out what the other answer is. And this is the tricky part, because there's formulas, but there's also just look at the picture and figure it out. So there's the angle that I don't have. That one in the second quadrant. But because of the symmetry, I know that this side over here is 0.824. It's not really an angle used very much. So if this is 0.824, can you figure out how to come up with what the green one is? This would have been easier in degrees probably. Let's say that's 60. What does that mean this angle is? 120. That's easy one. So where'd the 120 come from? What'd you do to get 120? Subtracted 60 from 180. So down here we're in radians, but it's kind of the same process. So how do I find this green angle here? If I know that this little piece is 0.824. Subtract it from pi. So the other answer is pi minus 0.824. Pi minus answer. So your calculator is great, but it only gives you one of the answers. 2.317. So for sine, it's the other answer for sine is always pi minus your first answer. But you don't want to memorize that rule. You want to be able to think about it and figure it out. Let's say cosine of x equals negative 0.1. All right, where's the cosine negative? What quadrants? Plan ahead here. What quadrants have a negative cosine?
2 and 3.
2 and 3, the stuff on the left. Now to find one of the answers, I'll do inverse cosine of negative 0.1. Inverse cosine, negative 0.1. 1.67. 1.671. So that's one of my answers. My other answer, cosine's kind of easy. What's that angle going to be? Because of the symmetry. Negative 1.671. So cosine is the easier one. It's always just plus or minus whatever the calculator gives you. Let's turn the page and do some more examples here. Eight cosine x plus 4 equals 0. On 0 to 2 pi. So we're restricted here. Finding all of them. So job 1, isolate the trig function. So hopefully your algebra skills are good enough that we don't have to write all these steps. Hopefully you can do the 2 steps in your head. And what does cosine of x equal? Negative 1/2. Good. So minus 4 divided by 8 would be negative 1/2. All right, this is cosine is negative 1/2. That's in the second and the third. And the 1/2 is the over 3 angles. So it's something over 3. So what's over 3 in the second quadrant? I'm calling on people here. Noah, what angle is over 3 in the second quadrant?
2 pi.
2 pi over 3. And Derek, what's over 3 in the third quadrant?
4
Good, 4 pi over 3. Now, be careful, again, you could say this is negative 2 pi over 3, and you'd land at the right spot, but that would not be between 0 and 2 pi. So make sure your answers are where they're supposed to be, between 0 and 2 pi. So this is a little bit of algebra and a little bit of unit circle is most of what today is. Number 2. Things are a little bit more tricky here. If I subtract 8 sine x, I get 6 sine x. And if I subtract 6, I get negative 3. So sine of x equals negative 1/2. This is just unit circle, unit circle, unit circle. Jake, where's the sign negative? What quadrants? The bottom 2. That's a great answer. 3 and 4, I guess, is the technical answer, but the bottom 2 is a really good answer. So right there and right there. Evan, what's the reference angle, or what's the denominator for a sine equaling 1/2? It'd be a 6. So I know both my answers are over 6. So Danny, give me one of those angles. Okay, so Danny is going the good. And when we did inverses, it was negative pi over 6. But now we have to find angles between 0 and 2 pi, so 11 pi over 6 is right. Brandon, what's the other angle that's over 6 there?
7 pi.
Good. 7 pi over 6. So again, a little bit of algebra to start the problem, and then your unit circle stuff. All right, number 3 is going to be weird because of the 2x thing in there. So let's hold off on the 2x for now. Yeah. Let's do the algebra stuff first. Tangent of 2x equals 1 over the square root of 3, which means square root 3 over 3. So that's the tangent 3 trick. So I'm kind of just going to ignore the 2x for now. So if the tangent of something equals root 3 over 3, let's just ignore the 2x for now. Let's see, where is the tangent positive? Cecilia, what quadrants have a positive tangent in them? The first and the third. Okay, so I need to be in the first and the third. Maybe I should have asked this first. Austin, what's the reference angle? What's the denominator? What's the reference angle that gives me a tangent of root 3 over 3? It's the tangent 3 trick. I think, what'd you say, Noah? I think it's 6, but don't take my word for it. And Austin said, I think it's 6 too.
I don't do the.
That's okay. But so however you get there, you've got to figure out some way that, yes, it's over 6. So I need over 6 in the first quadrant, Ava, and I need over 6 in the third quadrant, Toby. So Ava, what angle over 6 is in the first quadrant? That's the easiest question of the day. Pi over 6. Toby, hopefully not too much more difficult. What angle is over 6 in the third quadrant? What angle is over 6 in the third quadrant? This angle. 5 would be a little short of pi. I need to get past pi. So 7. And I still got that 2 thing to worry about. So pi over 6 and 7 pi over 6. How do I get the twice the number of answers? What do I do to get more answers? Do you remember? Add 2 pi. So if I add 2 pi to pi over 6, it's helpful if you can add fractions in your head here. If not, then you come out to the side and add 12 pi over 6. That would be 13 pi over 6. And add 12 to this one, you get 19 pi over 6. And the 2x means I need twice as many answers, so I can just add 2 and be done. Or add 2 pi to each answer. And then I need to divide by 2, or multiply by a half, probably an easier way to think, since it's fractions. So while I normally end up with 2 answers, this time I ended up with 4 answers, but that's because the 2x means twice as many answers. So that's probably what's most missed and most confusing on this section, is when the argument is 2x or 3x. Because other than that, the algebra is not real hard, and it's just knowing your unit circle. But the 2x and 3x stuff is what tends to throw us off. Number 4. What values of x from 0 to 2 pi are solutions to this equation? There's a 3x. Maybe we need to think ahead here. So how many answers do you think we'll have for this problem? How many total answers do you think we're going to have?
6.
Probably 6. Because usually cosine gives us 2 spots on the unit circle. But 3x means I'm thinking we'll have 6 answers. Question mark? But yes, we will have 6 answers. So a little bit of algebra to start with. Cosine of 3x equals 1 over square root of 2. That's a 3 right there. Cosine of 3x equals 1 over square root of 2. Let's fix that so it looks more familiar. Root 2 over 2. And the 3. So I'm not really worried about the 3 yet. So I'm thinking, where's the cosine? Don't worry about the 3x. Just where is the cosine root 2 over 2? So first question is, Gregory, where's cosine positive? What quadrants?
1 and 4.
Yeah, 1 and 4. All students take calculus, so we know we're in 1 and 4. Austin, what's the denominator that gives us root 2 over 2? 4. So Joseph, I'm over 4 in the first. In the fourth, you get the easy one. Audrey gets the slightly harder one. What quadrant, or what angle is over 4 in the first quadrant? Pi over 4. And Audrey, what angle is over 4 in the fourth quadrant? Good. 7 pi over 4. So 3x is equal to those things, but I need 3 times as many answers so that I can catch them all. So I need to add 2 pi to all of those answers. So pi over 4 plus, again, if your fraction skills, they need to be at least modest so that you don't have to write everything out. If I add 8 over 4, I would get 9 pi over 4. And if I add 8 more to that, I would get 17 pi over 4. And I can stop there because now I have 3 times as many answers as I normally need. On the bottom one, if I add 8 pi over 4 to that, I get 15 pi over 4. if I add 2 pi to that, 15 plus 8 is 23 pi over 4. And I can stop there because 3x, so I've got 3 answers. And then what's the last thing I do to get x by itself? Divide by 3. Or, what's a better way to say it when we're working with fractions? Multiply by a third. So pi over 12, 9 pi over 12, whoops, that one reduces. So that would be pi over 4, no, 3 pi over 4, 17 pi over 12. Because I reduced it. I reduced the 9/12. I wasn't paying attention when I divided by 3. Now I'm alert to that, so if I divide 15 by 3, I get 5 pi over 4. And then 23 pi over 12. So yeah, Audrey was right 5 minutes ago when she said we'd get 6 answers. She's unwilling to accept a high five. Number 5, and final. 1/2. Ooh, we haven't done one quite like this. How many answers do you think we'll get if there's a 1/2 in there?
1.
Probably 1. 1 answer? And let's see what happens. 1 answers. 1 answer. Singular. So tangent of 1/2 x equals, subtract 7, divide by 7, get -1. So tangent is negative. Cole, where is tangent negative? 2 and 4. Good. Angel, what's the reference angle? What's the denominator for where tangent is equal to -1? Or 1. Either way. Tangent is 1 in the middle where the sides are equal. So over 4. We're going to get through everybody today. So Landry, what's over 4 in the second quadrant? 3 pi over 4. And I'm out. I think I called on everybody. Emma, do you not have a popsicle stick? What's the over 4 in the fourth quadrant? 7. Good. And then I need to multiply by 2 this time. Although something weird's going on because I'm supposed to only have 1 answer, but let's multiply by 2 and see what happens here. So 3 pi over 4 times 2 would be 3 pi over 2. 7 pi over 4 times 2 would be 7 pi over 2. So I'm still looking at 2 answers, but we thought there would only be 1 answer. Does anybody see what the problem is here? Or how do I know which answer is right?
7 pi over 2 is too big.
Why is 7 pi over 2 too big?
Because it's more than 2 pi.
We're supposed to be between 0 and 2 pi. 7 pi over 2 is like, wait a minute, I'll just say it like you said it, that's too big. So my answer is 3 pi over 2. Officially, we would say it's outside of the, specified domain or whatever. But yeah, it's too big. Too big, so we throw it out. So Noah was right from the get-go. Only 1 answer, but be careful about picking the answer. Audrey?
Is that it?
Yes?
Okay, I got a question. If you could teach us how to store